Trigonometry, Chapter 2, Acute Angles and Right Triangles. Section 2, Trigonometric Functions of Non-Acute Angles. Video 5, Finding an Angle Measure Given a Trig Function Value. This series is based on content from Pearson's Trigonometry, 12th edition, by Lial, Hornsby, Schneider, and Daniels. In the previous video, we used the idea of coterminal angles and reference angles to calculate the exact values of trig functions. In this video, we'll investigate the same idea, but in reverse. Given the value of a trig function, can we recover the angles? For example, find all values of theta in the interval 0 degrees to 360 degrees, such that sine of theta equals negative square root of 3 over 2. Full disclosure, we're just basically solving a very simple trig equation. Down the road, we will have more complicated trig equations that will boil down to problems like this one. So this is a critical skill to have for future sections. All right, to solve this equation, think about how we would evaluate the function sine if we already knew such a value of theta. Well, we've already done that. First, we would find the reference angle of theta. We would also determine the sines of the trig function based on the trig function and the quadrant of theta, or rather its terminal side. And then we would evaluate the trig function at the reference angle. So there's some clues as to what transpired with some of these moves already, based on the answer we're trying to get, negative square root of 3 over 2. Well, let's start by determining the possible quadrants. This part's pretty easy. From the given equation, we can see that the sine function came out negative. In which quadrants is sine negative? Sine is negative in quadrants 3 and 4. So now we know what quadrants theta's terminal side could be in. So we're looking for something in quadrants 3 and 4. Now, we've already analyzed the negative sign to determine the quadrants, but what about the size of the value, its absolute value, the square root of 3 over 2? Well, this came from taking the sine of its reference angle, of theta's reference angle. So which acute angle has a sine of square root of 3 over 2? In other words, sine of what is equal to the square root of 3 over 2? You thought I wasn't kidding about, you thought I was kidding about knowing the 30, 60, 90 and the 45, 45, 90 triangles. I was not, I assure you. Since sine of 60 degrees, look at your triangle, was square root of 3 over 2, we know the reference angle was 60 degrees. So here's the two things we know about theta. It was either in quadrant 3 or 4, excuse me, quadrant 3 or quadrant 4, and its reference angle was 60 degrees. Thus, we place a reference angle of 60 degrees in each quadrant, then measure it from standard position, back from the positive x-axis. For example, here's a 60-degree reference angle in quadrant 3. Notice it's measured from the x-axis. But the angle we're looking for is theta from standard position, the one in green. How do we connect the two? Well, notice I put the blue semicircle on top because from the diagram, it's clear that this 180 degrees, which takes me from quadrant 2 to quadrant 3, and the additional 60 degrees from the reference angle totals the angle we're looking for. So theta is 180 plus 60, in other words, 240 degrees. Similarly, because we also had a solution in quadrant 4, here's a 60-degree reference angle in quadrant 4, but the angle we're looking for, measured from standard position, is the green one, theta. So how do these two connect, the green and the red? Well, they make a complete circle. And so since the green theta plus the red 60 equals 360 degrees, we subtract 60 degrees from both sides and get theta equals 300 degrees. The two desired values of theta are 240 degrees and 300 degrees. In general, we did the following to find the values of theta. Number one, we used the sign of the given value of the trig function and the trig function itself to locate two possible quadrants. Number two, based on the size of that given value, in other words, its absolute value, and the given trig function, we determined a reference angle. And thirdly, we placed the reference angle in the possible quadrants and measured from standard position. So these are the steps for solving equations like sine of theta equals negative square root of 3 over 2 in the interval 0 to 360. Now you try. Pause the video and try the following. Find the values of theta in the interval 0 to 360, including 0 but not including 360, such that tangent of theta is equal to 1, and the other one is secant theta is equal to negative 2 square root of 3 over 3. Pause the video, give it a try. All right, here's your fair warning. If you haven't paused the video yet, solutions in 3, 2, and 1. On each one, we explain the quadrants, the reference angle that we're looking for, and the final answers, of course.